Hello everyone. So we're going to continue our work with circles today, and we're going to look at inscribed circles. So a little bit more of some theorem practice today, and we should be good. Okay, so here we go. Inscribed angles. A major arc. So a major arc is the arc of a circle measuring more than or equal to 180 degrees. So that's this entire arc from A, C, B. So in this one, this would be arc, and that's how you write arc, A, C, B. And by putting that B in the center, or that C in the center, you're saying it's this arc right here. A minor arc is an arc that's less than 180 degrees, and this one would be from A to B. And since we didn't include that C, that's how you know it's the minor arc. And then a semicircle is an arc exactly measuring 180 degrees, and it's going to be base with a diameter. So I'm going to put a D there. So you're going to see it because the chord for that one is a diameter. A central angle. A central angle is an angle formed by two intersecting radii such that its vertex is at the center of the circle. Central angle theorem. In a circle or congruent circles, congruent central angles have congruent arcs. So, since this is x and this is 80 degrees, since it's a central angle, the arc is the same as the angle. So, x equals 80 degrees here. Okay. Now, let's identify the following in circle P at the right. For parts D through F, find the measure of each arc for circle P. So a semicircle. A semicircle is going to be from S to Q because that's the diameter it goes through, crossing through the circle. And you can either call this SQ, you could call it STQ, SRQ, whatever you want. I'm going to call it STQ. So it's arc STQ. We put it like a little arc above it. A minor arc. There are a ton of minor arcs in here. I'm going to do SR right here. So SR is my minor arc, but you could have said ST. You could have said TQ, you could have said QR, you could have said RT. Anything that's less than 180 degrees counts. A major arc. So for the major arc, I am going to do RTQ. Now I could call this RSTQ, but normally we just do 3 letters. RTQ is more than 180 degrees because it's more than half of a circle. So RTQ. You could have also done RQT. You could have done SQT. You could do anything that creates an arc more than 180 degrees. Okay, the measure of angle ST. Well, ST is here. So it is of arc ST. Well, the angle is 86, so the arc is also 86 degrees. STQ. So STQ, well, this is a semicircle. A semicircle is half of a circle. And so half of a circle is 180 degrees. And then RT. RT is from here to here. Now, I need to find this little piece. Well, this half is 145, which means, or sorry, this half is 180. And this portion of that half is 145. That means this section right here is 180 minus 145, which gives us 35. So I have 35 here, 86 here. If we add those together, we get 121 degrees. That's what you do. But I wanted to come say hi. So for the next part, inscribed angles. An inscribed angle is an angle with its vertex on the circle formed by 2 intersecting chords. So here's a chord, here's a chord, here's the vertex. We have our inscribed angle. The inscribed angle theorem is the measure of an inscribed angle is half the measure of its intercepted arc. So whatever this arc is, half of it is this angle right here compared to the arc right here. Meaning that the measure of angle DEF is half of the measure of arc DF. Okay, so let's try this out. What are the values of A and B? Ooh, we got a lot going on here. All right, so first let's find A. If PQT, that's angle PQT, equals 60 degrees, then double that would be the arc A. Arc A would be double that. So double 60 is 120. So A equals 120 degrees. because this is the inscribed angle and the arc is double the inscribed angle. All right. Likewise, we have an inscribed angle right here, trying to use different colors so you guys can see this. We have an inscribed angle right here for B. Well, we just found out that A is 120 and this right here is 30. So together that makes 150. And an inscribed angle is half of that. So half of 150 is 75 degrees. So that's what you're doing. I want you guys to try and do the next one. So pause the video and try and do the next one. Okay. So this is angle A right here. Angle A is going to be half of 190 because from here to here is 190. A half of that is 95 degrees. Here's measure of angle B. And it's half from here to here of 64 and 90, which is 154. And half of that is 77, I hope. Let me double check that in my head. Half, 45, 32, 77. Yep. Okay, measure of angle C. Okay. This is the inscribed angle. It's from 106 and from BAD. So 106 and 64. You add those up, you get 170. Half of that is 85 degrees. And finally, the measure of angle D. Measure of angle D is 106, 100, 206. Half of that is 103. Now we can double check this to make sure we did everything correctly. Because if we add them all up, they should equal 360. This is a quadrilateral. So let's add them all up really quickly. So we have 95 plus 77 plus 85 plus 103. And we have 360. So it does add up correctly there for us. Now I know this sounds crazy for the way it works, but it totally makes sense. And the reason that it's half is this 100 is counted as part of D, but it's also counted as part of A. That 100 right there is counted in angle A and in angle D. It can only be counted once if these add up to 360 and these add up to 360, which they do. It can only be counted once. Because of that, we have to half it, so it can only be counted once, or part of it can only be counted for both of them. If you need a little bit more explanation in that, definitely come join the Google Hangouts. All right. So since we know this, we have some corollaries. Corollaries mean thus, this is what's happening. So, two inscribed angles that intercept the same arc. So if this is my arc right here, angle B intercepts that, and angle A also intercepts that. They are going to be congruent because they both have the same arc. Also, an angle inscribed in a semicircle is a right angle. Because a semicircle is 180 degrees, half of that is 90, so it's a right angle. And then finally, the opposite sides of a quadrilateral, so here, inscribed in a circle, are supplementary. They're supplementary, meaning they add up to 180 degrees. So B and D should add up to 180 degrees. Okay. So measure of angle B and measure of angle D should add up to 180. That's what supplementary means. So let's see if we can do some work with this. So what is the measure of each numbered angle? So this right here is 1, and it's cut off. It's a semicircle. So 1 would be, since it's a semicircle, half of 180 is 90 degrees. All right, 2 is right here. Well, this one right here is this arc, meaning this arc is 76 degrees. And then likewise, 2 is going to be half of that, or 38 degrees, meaning these two are congruent. So the measure of angle 2 is 38 degrees because they share the same arc. They have to have the same angle measurement. Okay. Now you're going to try the next part. So I'm going to pause right now and hopefully you guys got this. All right. let's look at this. The measure of angle 3, because this is a semicircle, is going to be 90. The measure of angle 1, this is a semicircle, is going to be 90. Plus 1 and 3 need to add up to 180, so they're both 90. Now the measure of angle 4, 60 plus 80, because we got to add these two arcs, is 140. Half of that is 70. And since these two have to add up to 180, this is going to be 110 degrees. Also, because they all have to add up to 360, you knew that had to be 110 degrees. Okay. Now another theorem. Tangent chord angle. An angle formed by an intersecting tangent and a chord has its vertex on the circle. So here you go. The tangent chord angle is half the measure of the intercepted arc. So kind of like your inscribed angle, this right here, the measure of angle C, is going to be half of this measure right here, this arc measure. All right, so let's try this. In the diagram, SR, so this is tangent. We know it's tangent to the circle like Q. If PMQ is equal to 212 degrees, so that's the arc there is 212 degrees. What is the measure of PQR? So this angle in this arc. Well, like we said, it's going to be half of it. So this angle right here, half of that, or the measure of angle PQR is equal to 106 degrees. Remember, half. All right. Now you try the next one. So pause the video and you try. Now it's a little bit more difficult. So in the diagram, KJ. So line KJ is tangent to circle O. What are the values of X and Y? They're both angles. So the measure of angle X we need to find and the measure of angle Y we need to find. All right, let's start off. This right here is a semicircle inscribed angle. So I know right here is 90 degrees. Since I know that this is 90 degrees, this is 35, this Y needs to be 55 degrees. Okay, and then the other really cool thing is this is 35 degrees right here, which means this arc measurement right here is 70 degrees. So let me put that in. This arc measure right here is 70 degrees. And since this arc measure right here is 70, this tangent chord angle is going to be half of that, or 35 degrees. So this tangent chord is half of this arc, and this arc is 70 because it's double this, meaning an inscribed angle that also shares a tangent chord angle are going to be equal. Okay. Very interesting. There are some practice problems. If you want to pause and try these yourself, and I'm going to quickly go through them, you are more than welcome to. All right, it says find the value of each variable for each circle. The dot represents the center. Okay, so over here we have this adds up to 142 degrees. The whole thing has to be 360. So this over here is 218. So A is equal to 218. And then half of that will be B. So B is equal to 109 degrees. Here, A is going to be half because it's an inscribed angle. And half of 116 is 58. So A is equal to 58 degrees. 3, this is 90 degrees. Since this is 90 degrees, this is going to be double that. So A is equal to 180 degrees, which means this is the diameter right there. All right. For this one, we have a lot of letters. We have A, B, C, and D. Well, since this angle subtends the bigger angle, that means that this 108 tells me this arc is 108. Since this arc is 108, this angle in here is 54 degrees. So D is 54 degrees. Okay, now that we know that this angle is 54 degrees, I'm going to write that in here. We know that all of these have to add up to 180, so that's going to help us out a little bit. This is 156 degrees right here, this arc, and half of that has to be B. So half of 156 is going to be 78. So that's your B, because that arc is double B. Now, all of these are on a straight line, so they add up to 180. So 78 plus 54 is 132. 180 minus 132 is 48 degrees. So A is 48 degrees. And then C is the arc for the tangent chord angle, which means it's double 48 or 96 degrees. Okay. For number 5, all right, these two have to add up to 180. So 180 minus 68 is going to give us 112. So I know that A is 112. These two together have to be double 112. Double 112 is 224. 224 minus 104 is 120. So B would be 120. Again, I got that because 112 doubled is 224. These two have to be equal to double, or have to be equal to 224. 120 plus 104 is 224. All right. 71. Double 71 is 142. These two right here, C and 104, have to be 142. So C is going to be 38 degrees. Okay, for the last one, we need X and Y. X and Y are the corollary here. Two inscribed angles that intercept the same arc are congruent. So they're going to be congruent because they intercept the same one. And it's going to be half of this. Half of 72 is 36 degrees. So they're both 36 degrees. All right. For your activity today, you're going to be playing a game where you are practicing what we've learned over the last 3 days. So I hope that is fun. And you'll be sending me a screenshot of the game. I hope you have a great day. Bye.